Hello everyone, welcome to this video. My name is Emerson Akari. I'm a Google Earth Engine expert. In this tutorial, I'm going to show you how to apply Mann-Kendall trend analysis in Google Earth Engine platform. Actually, in this tutorial, I'm going to use Python programming language and make a bridge between Colab and Google Earth Engine. This allows us to use Python libraries for the satellite data analysis that could be a really beneficial option for the scientists to extract more valuable information easily. So in the first step, as I already actually pointed in the previous tutorials, first of all, we must make a bridge between Google Colab and Google Earth Engine. So there are two libraries that should be imported first. One of them is Earth Engine library, import EE, and another one is GEE map, as for example GEE. These two libraries are necessary to make a bridge between Earth Engine and Google Colab. As you can see, now the bridge is made, but now the bridge we didn't start the bridging yet because in the first step only the necessary library is imported. To make a bridge here, we must use authentication, authenticate Earth Engine, authenticate first, and then Earth Engine that initialize based on project you have or Google Cloud project you have. If you want to know about the Google project, Google Cloud project that you are using, just go to the code editor environment. In the right upper side here, you can get information about your cloud project ID. As you can see, my cloud project ID is like that, and just copy and paste it into the Colab initialize process. Run a code now, and now we can make a bridge. But here there is a problem about authentication. Now the problem is solved, and we have a pop-up about allowing connection. Click on allow, select your Gmail account that is already activated in the Earth Engine. Click on continue and again on continue. So bridging process is done, and now we can actually use data sets in the Earth Engine and also some functions in the Earth Engine with Python libraries combining together to get valuable information. For example, imagine that I'm gonna select a region of interest first. Let's go to the code editor environment and select your region of select your target area or region of interest through the drawing tools available here. For example, I'm gonna select a point in the Finland. For example, imagine that in the high latitude region, I'm gonna select a point here to assess the temperature trend and to do the trend analysis, temperature trend analysis in this region. For example, here, as you can see, a point selected. And now if you want to see the exact coordinate for the point here, just write a function as print, bring the geometry and get the coordinates like that. If you run a code in the right panel, you can see the exact location for the selected point. Just copy and paste it into the Colab environment. So make a new variable in the Colab environment. As you know, we are doing programming based on Python standards, and no need to actually no longer need to make var before the name of the variables. Just write the name of the variables. For example, the coordinate equals to the location, and then ROI must have geometry structure Earth Engine from Earth Engine library .geometry.point. Call geometry.point and enter coordinate or define the coordinate for the ROI. Run a code again, and here the ROI is created. If you run a ROI here, you can see the point with the same location already mentioned here. You can see that the geometry point, this is the same as you can see here in the Earth Engine and code editor environment. So once the region of interest selected, in the next step I'm going to call arrow 5 temperature data. Make a variable, for example arrow here, and through the search places on dataset you can find your target dataset available here. Arrow 5 monthly and daily dataset available here. I'm gonna use monthly time series data because for the time series analysis I'm gonna actually call a long or time span, actually a long-term period for data analysis from 1980s to 2024, and also it is better to use monthly data, aggregated data, to reduce number of samples engaged in the processing steps. So the monthly aggregate product is available, or land monthly aggregate. No matter which one of them you want to use, you can use this tutorial for all kind of climatological or Earth observation data available in the Earth Engine, but I prefer to use some sort of data that is available for long period of time. For example, if you go to the land arrow 5 land monthly aggregated product, here you can see it is available since 1950 with monthly frequency. That is very valuable assets for the long-term trend analysis. So, and also the land monthly data set is better because its spatial resolution is around 10 kilometer, and then we can have more detailed information in the data analysis process. Let's import it into the code editor. No need importing it is not necessarily to have the image collection in the code editor environment. Just I'm gonna actually tag or actually has a link direct to my data here, and also just I'm using the code editor as a simple sheet to write the data and coordinates that I'm gonna use in the Google Colab environment. So go to the link here and copy the link and paste it here. As you can see, the Earth Engine imported, and then through the select you can find your target dataset. If you go to the dataset information here, you can see the temperature band is available here for near air surface temperature at 2 meters is available. Just copy and paste it inside the select function, just like that, and then throw the filter dates, same as what we did before in the code editor environment. You can filter your data based on a period of time. For example, I'm gonna call the satellite data since 1970 to 2024, just like that, 2024. And now if you make a print from error, after a few moments you can see, for example, more than 600 elements is available. This is monthly aggregated product. If you collapse down here, you can see that for each date starting from 1971 band is available, and it is related to temperature at 2 meters. And it is very useful things, writing codes in the Python structure, because we can have same scripts as we had in the code editor environment, and aligned to the Earth Engine functions. We can use machine learning functions available in the Python libraries. That in this tutorial you can see how we can use Mann-Kendall actually function in the Python to combine with the satellite data that we have in the Earth Engine environment. So back to the code. As you can see, the satellite data called and region of interest selected, and now in the next step I need to get the value of temperature for the selected point since 1970 to 2024 with monthly structure, with monthly actually frequency, and then I'm gonna use this temperature data for Mann-Kendall trend analysis. So now we must make a function to reduce to actually subtract each temperature data from 200. I think there is a constant value to convert the Kelvin data to degrees Celsius. For example, if you go to the data properties here, you will find that the temperature data we have here, its unit of measurement is Kelvin, and we must subtract it from 273.15 to convert it to degrees Celsius. That's why here I'm gonna actually make a function that easily actually applies a subtraction process on each data. For example, the temperature variable equals to bring the era 5 data first and then make a loop structure through the dot map. Everything is same as co-editor until here, but instead of making a function in Python actually to make a function for the to apply a calculation on each available data in a loop structure, it is better to use lambda structure. And here you can see in the code editor, in the Colab environment, the rest of the code actually hinted by the platform easily and helps you to understand what should you do in the next step. For example, each input image has an IMG called for the lambda, and then the lambda returns each IMG that is subtracted from 273.15, and at the end I'm gonna actually copy the property of input images to the output. Specifically, the system time start is necessary for the time series analysis, and Mann-Kendall trend analysis is based on the time and temperature data here. So that's copy, same as code editor, that's copy properties. Let's copy properties from input IMG, get system time start for the output. System time start is a target property we want to get from the input to the output. So now let's see how it works. This is the temperature. And as you can see, again, we have 648 elements, but this time the temperature subtracted from 200 from the constant value 273.15 and converted to the degree Celsius with one system time start property that should be available for the further steps. In the next step, I'm gonna get the temperature value for the selected point that's already mentioned as a ROI in the code here. So make a new cell here and make a new function to extract the temperature and the date information. So here I'm gonna actually make a function as extval, means value extraction or something like that. When you want to make a function in a Python, it is necessary to start with def, define a function, and then we have the name of the function and input arguments then. So the input argument called as img, and instead of the curved bracket here, use actually colon here and press enter to write the function body easily here. So for example, first we want to have a variable that shows that actually including the temperature value for the selected point through the reduce region function. So make a variable as temperature value equals to get the input img, and then through the reduce region get the temperature value for the selected point. the arguments are reducer earth engine dot reducer dot mean. As we are working on a one specific point or single point, it is better to get the first value that's detected by the point. The geometry region of interest equals to the ROI, and scale equals to 10,000 meter, because the spatial resolution is 11,000 meter. You can set the scale as 11,000 or 10,000. No, actually, there is no clear differences between 10,000 or 11,000 in the final results here. So if you want to get it as a value, now get the values first, dot values, and then get the first item here. And then let's go for the date information or date value. From input img, extract the date first and convert it to the simple format as year, month, and day. Finally, the function returns a feature including two parameters, temperature and date. The spatial temperature will be known, spatial information will be known, and we will have two columns here. One of them is date equals to date value, and another column equals to temp or temperature, that's temperature included temperature values. So the function created, and now we must apply the function on each temperature data already created here. So now I will have a list, or now I will have a value list equals to, so we can have temp and date values equals to, so get the temperature data and apply the function through the map, and name of the function should be entered here. So the temperature map, temp date val, write it to see the final results. So it takes actually a bit more, because it is including the process of date and temperature extraction for the selected point. And here code returns a feature collection instead of an image collection. Now we have a feature collection. For each date we have a feature including two columns, one of them date and another one is corresponding temperature. So now we want to actually export it from the feature collection to the data frame or table structure for Mann-Kendall analysis. To do this, make a new cell and write the code like this. Make a list structure here. Data list is a new variable equals to get temperature, date, and value, then convert it to the list structure according to the number of records we have in temperature value. So then through the .getInfo we can return it from the server side to the client side structure. Finally, the data list will have such kind of structure. As you can see, for each date we have a property. Inside the property, under properties class, we have subclasses or sub information as date and temperature. So in the next step we can actually have a list of date and list of temperature. Make a new cell again. So here temperature list equals to, make a bracket first, and then each item in the properties, each item from the properties and temperature for item in data list. So write like that, temperature list. So as you can see here, we have a list of temperature. So you can add any other name instead of the item. So now from the data list, actually I called each parameter as an item that is extracted from properties and temperature that is under properties information. So it's very simple. And finally, you have a list of temperature data starting from the start date and ending to the end date. And what is and also the question is how we can have the date information. It is also very simple. Use the same structure, but this time for the date list. As you remember that under property information, we had date and temperature. Temperature already extracted as a list, and now turn to the date. Again, from items under properties, properties, find date information and from data list. Finally, the date information will store in date list variable. Run a code again, and here it is. You can have a list of dates starting from 1970 to 2024. So there it is. So now you can see the variables through the left panel available here. The temperature list and also the date list, both of them created with 648 items. Now we must have date list and corresponding temperature under a same table. To make a data frame or table, Pandas a library is necessary. So now import Pandas as PD. As you may know, the Pandas is one of the most popular and well-known libraries in the data science world that allows you to do everything or analysis, all necessary analysis for the data that are stored in the table structure. So import Panda library here and then make a data frame. So from Panda, the data frame function allows you to have a data frame with two columns. One of them is date equals to date list, and another one is temperature equals to temperature list, and run the temperature data to digit number. So get a print from data frame here, and as you can see, a data frame created from start date to end date, and for each date you can see the corresponding temperature that could be beneficial for the further studies. This data set or this data created from satellite data available in the Earth Engine and using the connection between or bridging between Colab and Google Earth Engine platform. So in the next step, actually you can save this data frame into your system for the further analysis, or you can continue process for the time series analysis and Mann-Kendall trend analysis. First of all, I'm gonna show you how to save this product easily. So for example, the created data frame could be saved as a CSV file that can be opened into Excel and statistical softwares for the further analysis. Temperature dataset .csv format. So if you run a code in the left panel, after a few moments, you will have a temperature dataset here that you can see it's available, and you can actually expand the data to have a look on the data. And if you want to download, just click on download here and save it into your system. It's very, very simple. As you can see, the temperature dataset is created and you can have it as an Excel file available here. Back to the code now. And then as you can see, the temperature dataset now is created. Now the question is how we can find the trend in this data. And also we want to know that if temperature has decreasing trend or increasing trend. So first of all, we must convert the column date to the date format. So let's get the date column and use Pandas to date time for this conversion. Pandas to date time allows you to convert the date to the date format that is readable by Python. So after this, I'm gonna actually convert this data from monthly variations to the annual frequency. It is also very simple here. Using Pandas library, you can do all of this stuff easily and without any challenge. Here, annual data frame equals to get the data frame and then resample it to the annual structure or year based on the date field actually. So for each year, I'm gonna get the average temperature, throw the mean, and run the output values into 2 digits only. So df annual, write it again, and as you can see here, the date indexed for each year and also temperature is available here. And now we can plot the temperature variations over 50 years ago. So there are a lot of tools in the Google Colab and Python programming language for plotting and designing the output. But here I'm gonna use the simplest one, just show something to understand about the trend and changes. But in the other tutorials, actually I will plan to make some to give you some advices about how to do the visualization, but it is not the concept of this tutorial. In this tutorial, just I'm gonna talk about the time series analysis using Mann-Kendall, but before that we can actually use the recommended plot here to get information to have to see actually how the temperature changes. For example, here as you can see, the temperature is changing and also seems there is an increasing trend since 1970, but we don't know if this temperature actually this increasing temperature is significant or not, and also we don't know the increasing trend starts from when exactly. These are kind of information we want to understand before trend analysis. The one side of trend analysis is what you can see in the plot, but the other side is something you can get statistically. That is very, very important because it helps you to interpret the changes over the years. So if you want to use as you may know, there are different methods and different functions for the trend analysis, but if you are working in the earth science, definitely you know that the Mann-Kendall is one of the most popular functions in the earth science and climatology for trend analysis, and also it is suggested and recommended by various papers and articles. Just if you search on Google Scholar about Mann-Kendall and climatology, you will find unlimited papers using this function for the time series analysis. So, but before go through the Mann-Kendall process, we must actually install Mann-Kendall function in the Colab environment because it is not already available. But installing Mann-Kendall or any other functions is very, very simple in the Colab environment, and you will have no serious challenges here. For example, just write pip install, for example, Mann-Kendall, and run the cell. After a few moments, Mann-Kendall function created easily. So after installed or installation, you must import Mann-Kendall as, for example, mcop function here. So make a function as make a variable as mctest equals to from mc library called original test. So based on annual dataset, actually for annual dataset, I'm gonna get Mann-Kendall test for this data. Remember to print the result here, and as you can see, according to the Mann-Kendall, there is a significant increasing trend in the temperature. So how we can say it is significant? Because the p-value shows that actually the p-value is less than 0.05, meaning that with 95% confidence we can say, okay, the temperature has increasing trend. And also z value is very important, that shows how increasing trend is strong and also positive. For example, when the z value is around 0, meaning that the increasing trend is very, very weak. But when the z value is more than 2 or 3, shows that this is very, very strong trend. And also the tau shows the slope of changes or a slope of increasing trend that ranges between 0 and 1, and also when it is 0.4 shows there is increasing an upward trend that is really, really strong, same as the z value. So and now statistically we can confirm that there is a significant increasing trend in the temperature for the high latitude region for the selected point. But another question is, since when such increasing trend started? This is a question that is not answered by the Mann-Kendall test, but you can find the solution through the Pettit test, another machine learning and statistical analysis methods available in the Colab environment. As you may know, such functions, Mann-Kendall and Pettit test, not available in the code editor environment. But if you work on a Colab environment, you can use Python libraries, machine learning tools, and satellite data and Google Earth Engine capabilities together to get to extract more information. And also this helps you to actually improve the quality of your studies. So now another functions or another library here is homogeneity library that should be installed first to answer the question about the year of starting increasing trend. Install homogeneity. So install another library, homogeneity, like that, and import it, import homogeneity as ph. So here we want to use Pettit test equals to from homogeneity dot Pettit test allows us to answer this question for annual temperature data. Let's print the Pettit test here. Let me to stop it first and run it again. After a few moments, as you can see, the H is true, meaning that actually there is a significant increasing temperature in this region, and it started from 1998, the end of 1998 or 1999, and as you can see, and it started significantly. It is very important. Maybe you can see the increasing since 1970, but significantly it's started from the late of 1990s here, means since here. Statistically and significantly it starts from here, this date, and as you can see, before the break point, the average temperature was 2.8 degrees Celsius, but after the average, it 2 degree increased. The average temperature in the second step, actually, the after selected date, the average temperature increased by 2 degree or around 1 point value, for example, increase more than 1 degree Celsius after the breakpoint date. And you can see that how much actually Python and libraries can help us to combine facilities in the Earth Engine and Google Colab to extract more information. I hope you like this tutorial, and also the code example is available below the video on YouTube channel, and you can find it easily and compares mine with yours. And if problems still exist, you can reach me out through the comments, and then I will be happy to answer your questions as soon as possible. Thank you for your attention, and I'm asking you to share this tutorial with remote sensing community to help each other to improve the knowledge and skills about Earth observation data analysis.